Okay, what I have here today, I have a TI-84 calculator, and it's connected to a calculator-based ranger, also called CBR. And what the CBR does is it simply measures distance. It measures the distance from here to the object closest to in front of it. So what we're going to do today is I'm going to have one of my children come up here, and he's going to stand in front of the motion detector, and when I say go, he's going to walk forward, and he's going to walk in such a way that hopefully we will get a nice straight line. You ready?
Mm-hmm.
Go. Okay, very good. Okay, so you saw how I gathered the data. Now that we've gathered the data, we need to examine the data and come up with equations. So, under my lab, in the Project 1 tab, you're going to find an Excel file called linear data. You're going to open that file and simply copy all the data. So I highlighted it, Control C. Then you're going to go to www.desmos.com. And once you get there, click on Start Graphing. This is a free online graphing calculator. And so this is what we're going to use to explore the data. Paste, just Control V, or I could go edit, paste, I suppose. And you'll see it draws the data for me. Now, you'll notice this data is not perfectly aligned. We don't expect it to be perfect, but it's basically linear. Now, one thing I notice is I'm wasting a lot of my graphing area here. I really don't need any of this. I really only need the first quadrant. So you might want to come up here, click on Graph Settings, change it so that your X goes maybe from -1 to 6. Looks like it would be plenty. And then just click off it. Okay, you could change your Y values too if you wanted to. You can move it around just by clicking on it. If you have a scroll bar on your mouse, you can zoom in, zoom out. Just get something that looks decent. Okay, so what you're going to do in this project is you're going to pick 2 points, and you're going to use those 2 points to find an equation of the line, an equation that matches this data. And then you will also use technology to compute the regression to find the line that best fits this data, and you'll compare them. Now, when you go to pick your 2 points, you want to be clever. For example, you probably don't want to pick these 2 points, because if you pick these 2 points, the line that goes through isn't going to match this line very well. You probably want to pick a point somewhere down here, a point somewhere up here, 2 points that look like when you draw the line, it's going to match your data pretty well. And if you simply click on 2 points that you like, it will give you the X and Y value. You know, you don't have to pick those 2 points. Those are just 2 that I liked. But pick 2 points that look reasonable and use those 2 points to find the equation of a line. Okay, I'm going to open up a different data set here, and I'll show you how to enter the equations in with the data. Okay, so here's a different data set, still fairly linear. I'm not sure where I got this data set from, but it'll give you an idea of what you need to do. So once again, what I would do is I would pick a couple points that looks like the line's going to go through them, and I want to figure out the equation of that line. I find the slope, and then I use the slope to find the intercept. And you want to type it in. To type it in, you're going to come up here, you're going to go to expression. So this one looks like y equals, oh, I'm just actually going to guess. It looks like my slope was about -1.5. And then my y-intercept looks like it's going to come up and be about 7. Alright, so not a great guess. Not terrible for just guessing though, just eyeballing it and looking. Okay, so hopefully when you find your 2 points and you find your equation, it'll match much better. So you're going to compute that equation and answer some questions about it. And then you're going to compute the regression equation. To compute the regression equation, you're going to come back here, you're going to add another expression, and you're going to type in y1, notice y1 is from the data down here, equals m, oops, not equals, I'm sorry, you use twiddle. And this thing twiddle which is on the button next to 1, tells the computer that we want to approximate. mx1 plus b. So notice y1 and x1 are the data variables here. And it tells you the equation that fits this data best is y equals mx plus b, where m is minus 1.4034 and b is 6.5453. Okay, so that's how you're going to use Desmos. The last thing you're going to want to do in Desmos is to get a copy of your graph and put it into a Word file, the Word file that you're going to type up to answer these questions. Now, in order to do that, over here, if you haven't signed in, you're going to have to sign in. You're going to have to create an account. Only takes a second. If you're signed into Google, you can just connect it with your Google account. Then, you're going to come over here to Share Graph, Image. And it will give you an image. You right-click, Copy Image, and then you can go to Word, and you'll be able to paste it in. Okay, so that's the basics of using Desmos. Any questions, of course, send me an email and we'll take a look at it.